Good afternoon. Welcome to another session of CSEC Physics Past Paper Workout. We're just going to go right into the questions. Question 1. Which of the following instruments is suitable for measuring the diameter of a human hair? So, a human hair has a very small diameter, which falls in the micrometer range, and therefore only the micrometer screw gauge is suitable for doing such small measurements. The answer should be D. Question 2. 0.0000462 Newton expressed in standard form is. Now, whenever we are writing a number in standard form, we know that the index must be negative if the number is less than 1. So all of your options has the correct notation in terms of the base number, 4.62. So we have to choose the correct index. And if we look at how many places you move the decimal point, then it should be 5. And so your answer is 4.62 times 10 to the negative 5 Newton, which is A. Number 3. Item 3 refers to the following measuring cylinder, which is used to determine the volume of a liquid. And you are to read the volume here. So we notice that the bottom of the meniscus is at 7.5 cm cube. So our answer should be 7.5 cm cube, which is B. Number 4. In an experiment to locate the center of mass of a sheet of cardboard, a plumb line, that's a string with a small mass on the end, is used. The plumb line is used to, we have to find out what the plumb line is used for. Now, a plumb line is used to determine the vertical of an upright surface, and therefore the most appropriate answer would be C, to show which points are vertically below the pivot. That's the point from which the cardboard is hung. The answer should be C. Number 5, you are shown part of a thermometer, and you are to read the correct measurement. What is the reading shown on the thermometer? Now, what you can do is to count the number of divisions between two numbers that you are sure about. So between 80 and 90, you have 5 divisions. So it means that each division represents 2 degrees, and the thermometer is at approximately at the 4th division from the 80. So 4 times 2 is 8, and so that's 88 degrees. And your answer is A. Number 6, sorry. When standing on the moon, the mass of an astronaut is 70 kilograms. When he returns to Earth, his approximate weight will be. So weight is mass times gravitational field strength, which is approximately 10 newtons per kilogram. So when we multiply the mass times the gravitational field strength, we get 700 newtons, and that is D. Number 7, which of the following is a derived unit? Now we know that Kelvin, K is for Kelvin, and that's the base unit of temperature. S is for seconds, and that's the base unit of time. While kg is the SI unit of mass, and that leaves us with meter cube or cubic meters. So that's a derived unit, and your answer is C. Number 8, an object of mass M is attached to a spring balance and its weight W recorded. What will be the result if the object is taken to the moon where the gravitational field strength is less and weighed. Now we know that mass doesn't depend on location. However, the weight is proportional to the gravitational field strength, and therefore the mass of the object on the moon should be the same, while the weight will be less than the original weight, because the gravitational field strength on the moon is less, and so we have mass equal m and weight is less than w. So that's A for your answer. Number 9, a solid object X floats in mercury and sinks in water. Another object Y floats in both mercury and water. Which of the following statements is true about X and Y? And we know that objects float in liquids which have a greater density, but will sink in liquids which have a lower density. So therefore, if X floats in mercury but sinks in water, it means that X is less dense than mercury but more dense than water. Y floats in both mercury and water, which means that Y is less dense than water, and therefore X has to be more dense than Y. And so your answer should be B. Number 10, a glass marble X moving at a speed 6 meters per second collides head-on with an identical stationary glass marble Y. What is the speed of Y after collision, assuming that X is brought to rest? So in the law of conservation of linear momentum, we know that total momentum before collision is equal to total momentum after collision. And since X was moving while Y was stationary, then the initial momentum of X will be the total momentum. And then after the collision, X is brought to rest. So the total momentum is due to Y alone, and therefore the momentum of X should be also equal to the momentum of Y. And therefore, because the masses are the same, then the velocity would be 6 meters per second. So that's C. Number 11, which of the following features must be present in a stable, well-designed racing car? And stability depends on mainly two factors: a low center of gravity and a wide base area. So A matches one of our criteria. Number 12, when two bodies collide, momentum is conserved. What is this saying? So conservation of momentum implies that the total momentum of the bodies remain constant, and therefore we should have D matching our fact here. Total momentum of the bodies before impact is equal to the total momentum of the bodies after impact. So D is your answer. Number 13, which of the following expressions can be used to find the speed of an object? You know that speed is the rate of change of distance, and therefore the answer is C, distance traveled divided by time taken. We can look at the other options. Change in velocity divided by time, that's equal to acceleration, while change in displacement over time is equal to velocity. Distance traveled times time taken, that would not give us a useful quantity. So the answer is C. Number 14, pressure in a liquid can be calculated using the formula P is equal to rho GH. Which of the following sets of units will give the pressure in the SI unit? All right, so in order for us to get the SI unit, we have to have all SI units for the other quantities. So the SI unit of pressure is in kilograms per cubic meter. SI unit of the gravitational field strength should be in newtons per kilogram. And the SI unit of height, which is a distance measurement, should be in meters. The answer should be B. Number 15, which of the following sources of energy are classified as renewable? Renewable energy sources are those that are basically inexhaustible or cannot be finished. And so all of these apply. And so your answer is D. Number 16, the heat capacity of a substance is defined as the amount of heat energy. And the definition of heat capacity is the amount of heat energy required to change the temperature of a substance by 1 degree Celsius or 1 Kelvin. So D is the option that matches closest. And so our answer is D. Number 17. When a ball is thrown vertically upwards and reaches its maximum height, it has, so at maximum height, the ball would have maximum potential energy, and since it is stationary for a very short period, it will have the minimum amount of kinetic energy. So we're looking for an option which says maximum potential energy and minimum kinetic energy, and that is C. Number 18, we have a graph of temperature versus time. The graph shows that solidification started at Q, during which of the stages is the substance in the liquid phase. Solidification is the process in which a substance changes from liquid to solid, and therefore if Q to R is showing solidification, so it started at Q and it will finish at R, then it means that between P and Q, the substance would be a liquid, because it would start to solidify at Q and finishes at R. So P to Q would be the stages, the time when it is a liquid. So between P and Q, so that's D. Number 19, which of the following processes is most likely to account for the fact that pot handles are usually made of wood or plastic? What we know about wood and plastic in terms of thermal conduction is that they are poor conductors of heat, and so we are trying to minimize conduction in that case. So the answer is A. Number 20, to check the upper fixed point on a thermometer on the Celsius scale, the thermometer is placed in. So the upper fixed point, otherwise called the steam point, is the temperature of steam above water that is boiling at normal atmospheric pressure. So D matches our fact. The answer should be D. Number 21, in the pressure law, which of the following statement is true? What does the pressure law say? The pressure law states that the pressure of a fixed mass of gas is directly proportional to the absolute temperature if the volume is constant. So we have mass is constant and also volume. So pressure is constant, that's not correct. Volume is constant, that is correct. The answer is B. 22. Who was responsible for arriving at the conclusion that measured amounts of electrical and mechanical energy can be converted to proportionate amounts of heat energy? And we know that, well, we know that Newton didn't do anything on heat. Rumford did experiment, but he did not do any calculations. Coulomb was known more for electricity. And so Joule is your answer. Joule did experiments that showed that during energy conversion processes, there was an exact equivalence between the initial and final forms. The answer is Joule. 23, a student carries out an experiment to determine the specific capacity C of a solid using the electrical method. Which of the following equations should be used? So several things here to consider. We first have to know that energy is equal to power times time. But when we are dealing with electrical power, we use equation current times voltage. And therefore, current times voltage multiplied by time would give us the energy. And we also know that the heat that is lost by the heater would be the heat absorbed by the solid. So if IVT is equal to MC delta theta, then C should be equal to IVT divided by M delta theta. So all we do is transpose for C in this final equation here. The answer should be C divided by, IVT divided by M delta theta, and that's C. (24) Which of the following is not an example of evaporation? What is evaporation? It's really a spontaneous process, and it can cause liquids left open to the air to gradually get less. And the only one that doesn't fit that description would be D, because all of the others imply some amount of evaporation. The answer should be D. 25. This is a diagram which shows a test tube of water being heated at the top, while there is a piece of ice wrapped in gauze at the bottom, and the water boils before the ice melts. Now, what is this showing? It's showing that water is a poor conductor of heat, since the water at the top here boils before the ice melts, and therefore we know that the heat must not have been traveling properly to melt the ice, because it is easier to melt ice at 0 than to get water at 0 to boil. All right, so it's showing that water is a poor conductor of heat, and so C is your answer. Number 26. The energy required to change the state of a substance was determined to be EH. If the mass of the substance was doubled, the new value of EH will be. Now, in the equation, EH is equal to M times L. The latent heat L is a constant. So if L is a constant, it means that EH and M are directly proportional to each other. And so when we double M, EH will also double. The answer is A. Number 27 refers to the following diagram, which illustrates a longitudinal wave chain produced on a slinky. Which of the following distances represent the wavelength of the vibration? All right. So the wavelength is the distance, or can be taken as the distance between two successive crests or two successive troughs. However, we have, in this case, we have compressions and rarefactions. So sorry about that. We should have between two successive crests, compressions or two successive rarefactions. However, we see where two successive compressions are between C and E. So C to E would be your answer. So C is your answer here. Number 28, which of the following electromagnetic waves has the shortest wavelength? And we know that radio waves have the longest wavelength, while gamma rays have the shortest wavelength. So our answer should be C. 29, in the following diagrams, X and Y represent two wave pulses superposing on each other to give a resultant R. Which diagram best illustrates the principle of superposition? So the principle of superposition states when two or more waves meet at a point, the resultant wave has a displacement which is the algebraic sum of the displacement of each wave. So which of these show that R is the algebraic sum of the of X and Y? So this doesn't show that, A doesn't show that, B doesn't show that, C doesn't show that, D shows, because we can consider this pulse to have a positive sign. It's going in a certain direction, while this pulse is going in the opposite direction. And so when we add positive and negative, which have the same numerical value, then the answer will be 0. So you get no resultant wave, and your answer is D. Number 30. If sounds of different frequencies are played in succession, in which of the following properties would a change be detected? All right, what do we know about frequencies and sound waves? The frequency of a sound wave determines the pitch. So what we detect as a pitch is a function of the frequency, and therefore the pitch would be affected. So the answer is A. So Miss Rose is supposed to come in now. I'm not sure. Miss Rose, are you there? All right. Miss Rose doesn't seem to be on yet. Someone is asking about going over, but remember we are working on a time limit. So we'll have to probably restart a meeting for that. All right, going to 31. The note from a drum is louder when it is struck harder because the sound waves produced have a greater. Again, this is about sound waves and the loudness. So what we perceive as the loudness of a sound is actually based on the amplitude of the sound waves, and therefore amplitude is your answer, B. Number 32, which of the following are laws of refraction? So we know two of the laws of refraction. Sin I divided by sin R is equal to a constant. And the second one, incident ray, the refracted ray, and the normal all lie in the same plane. So 1 and 3 applies. Number 2 is actually a law of reflection, and therefore that is not a part of the answer. So 1 and 3, that is B. Number 33, which of the following equations regarding units of physical quantities is not correct? So you really have to know your units now. Coulomb is actually equivalent to the ampere second. The volt is equal to joule per coulomb or ampere ohm based on the equation. So you can write your equations and check. Joule is equal to coulomb volt or volt coulomb, written as coulomb times volt in C. So it's coulomb volt or volt coulomb. And watt is ampere volt. So which one of them doesn't apply? So we see here watt, 1 watt is 1 volt times 1 coulomb. That is not correct. All right. The answer is D. Number 34. A ray of light leaves air and enters glass of refractive index 1.6. The angle of refraction is 27 degrees. What is the sign of the angle of incidence? So what we do is write our equations, N is equal to sine I divided by sine R, and N is equal, we are given N to be 1.6, so we replace N with 1.6. So 1.6 is equal to sine I divided by sine 27, and then when we transpose the equation for sine I, we're going to get that sine I is equal to 1.6 times sine 27, and that is C here. Number 35, in which material would the light waves have the slowest speed? Now, the speed that light travels is based on the refractive index of the material, and it travels slower in materials that have a greater refractive index. And we see here diamond has the greatest refractive index, and so it would travel slowest in diamond. And your answer is D. Number 36, you have a logic circuit. Here you have inputs A and B, outputs C and D. First symbol is that of an AND gate, while the second symbol is that of an OR gate. And so we know that C can only be high if A and B are high, and D can be high when either A or B are high. So if A and B are both 0, then we do not expect to get a high at either C or D. And so your answer should be A. Number 37, which of the following combinations of ammeter characteristics is correct? So we have resistance in one column and connection of ammeter in another column. What we know is that ammeters should have low resistance, so they do not affect the overall current in the circuit, and they are also placed in series. And so, which of these match with what we have here? We have low resistance and in series, so A is their answer. Number 38, we have a graph of current against time, and we're to find out what is shown at I. Now, most of these values may not be familiar to you, but you can look at the fact that the current I is at the maximum. So we see that's a peak. All right, the peak value. All right, the peak value is the maximum value of the current. And so your answer should be D. All right, number 39. You have two graphs. And so both have current against time. And what we see is that the time is in seconds in both, and the current is in milliamperes in both. So what we have to do is look at how the graph goes up and down. All right, current with the greater frequency. The frequency is the number of cycles per second. All right. So what we have is that in graph 1, we have one cycle being completed in 0.01 seconds, while in graph 2, one cycle is completed in 0.02 seconds, and therefore the greater frequency is in graph 1, and the peak value now are the same. They are at 2.5 in both cases, so neither has a greater peak value, while the current with greater frequency is shown by 1. And so your answer is D. All right. Number 40. Is Miss Rose here?
Yes.
Miss
Good evening,
Rose.
everyone. All right, so we're kicking off at question 40. A glass rod is rubbed with a piece of silk and it becomes positively charged. Now the question asks how it is that the glass rod becomes charged. Now we know that electrons are actually the particles that are involved in charge transfer. Because electrons are negatively charged, if an object loses electrons, then it's going to become overall positively charged. All right, so our answer there is B, losing electrons. right? Right. Which of the following diagrams represents the electric field existing between two oppositely charged point charges? Now, in electric fields, we draw the field lines always going outwards from the positive and towards the negative. So that would give us option A. Now, a voltmeter has a very high resistance, and then it asks us why that is. Now, voltmeters are always connected in parallel with a component, so that would eliminate options B and D. And of course, we don't want the voltmeter to affect the circuit because we don't want it to disrupt any of the other readings for current or anything. So the answer there would be A. Which of the following statements about insulators are true? Now we have three statements there, and the important thing to remember is that in insulators, the electrons are not free to move about. All right, so it means therefore that option 2 is false and option 1 is true, and we know that we can charge insulators by rubbing, so that's B. Right. Now we have a diagram here that shows that we have a small negatively charged dust particle that is midway between two plates, and it's observed with a microscope. Now we are asked to show or to tell which direction the dust particle is going to move in when the switch is closed and current starts to flow. Now basically, negative charges will be attracted to positive charges, or opposite charges will always attract. So since the dust particle is negative, it will want to go towards the positive side or the positive terminal, which is the long thin stroke in the cell. So it means that the dust particle is going to move downwards, and that's C. Number 45. Now we have a simple AC generator, and we want to know which of the graphs is going to be produced by two complete rotations of the armature. Now, for an AC generator, one complete rotation is going to complete half of a cycle, basically. So you'd have half of or a full cycle from one rotation of the armature, and two rotations would therefore give you two rotations. So we have the diagram there for better explanation. So each turn will produce a complete cycle. That's D. Number 46. You're given some equations there, and you're asked which of them shows the correct relationship in order to find the combined resistance of resistors that are in parallel. Now the relationship is that the inverse of the total resistance is equal to the sum of all the inverses of the individual resistances. So that's option B. All right, number 47, we have a circuit diagram here, and it shows that we have two resistors that are in parallel with each other, and it's asking which pair of values for I1 and I2 would be correct. Now remember that current flow is inversely proportional to resistance. So in other words, the greater the resistance, the less current will flow. So for the first resistor, we have a resistance of 2 ohms, and the second one is 4 ohms. So it means that less current would go into the 4 ohm resistor and more current would go into the 2 ohm resistor. And we have the full explanation there. That's option D. Number 48. When excess current passes through a fuse, which of the following is the sequence of events? Now, for a fuse, what happens is that once excess current starts to flow, that heat melts the wire. So the wire gets hot, and then the wire melts, and that is what causes the current to get cut off. So our answer there is B. Number 49, which diagram shows the magnetic field between a bar magnet and a piece of iron? Now, whenever a piece of iron is placed near to a magnet, it's going to induce a pole in the piece of iron. And we know that magnetic field lines run from north to south. So that would make our answer C. All right, which of the following diagrams represents the current potential difference relationship for a metallic conductor at constant temperature? Now, metallic conductors are what we call ohmic devices or ohmic conductors, and it means that they obey Ohm's law. So that means that if you plot current against voltage, you will get a straight line through the origin with a positive slope, and that's B. A device which converts sound into electricity is a loudspeaker, and that's option A. Amplifier will just magnify the voltage signal, whereas motors are responsible for converting electrical energy to movement or motion or kinetic energy. So that's A.
It's B, Miss Rose, B.
Oh, sorry, B. Oh yeah, I didn't see the microphone one. Yeah. All right, item 52. We have an electric circuit that has a cell and two filament bulbs. Now, if you look at the circuit, you realize that there is just one path for the current to flow, which means that it's a series circuit. So we just look for the option that has the two bulbs in series with each other, and that's option C. Okay. Number 53, magnetic induction occurs when, and we have some options there. Now, as we had just discussed earlier, one example of magnetic induction is when you have iron nails becoming magnetized, and that's because the magnetic material becomes magnetized. That's B. Right? 54. Isotopes of an element differ from each other in that they have different, we have our options there now. Isotopes are basically they are elements which have the same number of protons or electrons, but they have different number of neutrons. So the mass number is going to be different. So that's C. All right, 55. Which graph shows how the activity of a radioactive source varies with time? Now, whenever we have radioactive decay, it occurs exponentially. So we have to look for a curve. And the curve that shows exponential decay is D. Right? 56. According to the Rutherford-Bohr model of a neutral stable atom, and we have our statements there. Now, basically for a neutral atom, the number of protons and the number of electrons are equal because it is electrically neutral. So that's B. All right. Number 57, which of the symbols would be possible for an isotope of a nuclide that has X and the mass number is A, the atomic number is Z. Now, the atomic number is going to be the same for an isotope, so we look for the option that has Z for the atomic number, which is D. Right? And isotope of uranium, and we have the structure there or the configuration, and it changes to thorium. Now we know that alpha decay will result an in a species actually losing a mass of 4, and then it will lose 2 electrons as well. Right. Sodium decays into magnesium 24 with the emission of a beta particle, and we have our equation there. Now we need to remember that Sodium 24 decays into magnesium 24 with the emission of a beta particle, and we have an equation that is incomplete that we want to basically fill in the correct particle that would complete the equation. Now, whenever we write equations, we need to make sure that we balance them in terms of mass and charge. So when we look at that, we know that the missing number at the top is 0 and -1 would be at the bottom. So C and D would be eliminated because helium nuclei don't have those characteristics. So that would leave A for our answer. All right. Which of the following statements about radioisotopes is true? And we have some options there. Now, as hard as it may be to believe, we actually do use radioisotopes in medicine sometimes. For instance, in cobalt-60 is the one that I can recall. We use that in tracing cancerous cells. All right, so the answer there is C. All right. Now over to you, Mr. Campbell.
Miss Rose, remember that I did most of it. All right, any questions, guys? Anything you want to go over?